down into position. Okay, so what I'm going to do is press and hold D, which will bring up the pivot move tool, and then press and hold V at the same time and V-snap to the end here. This gives me a point of reference that I can work with, and then I can just bring this down and V-snap to there, so we know that the pivots are in the same place. Okay, so now we have our two coils. One is in compression, one is in extension. We do have obviously some transforms and some history, so what I'm going to do is I'm going to select the expanded coil, and I'm going to freeze its transforms initially. Okay, this will mean that all the values are 0 and the scale is a uniform 1, but I'm also going to reset its transforms because the helix tool actually changes its height from the center. And what we're about to do is create a blend shape between these two objects, but the blend shape would also operate from the center, expanding uniformly in both positive and negative y. And we don't want that. We want to have a point where we can expand from. I'll show you this. So let's select that. Let's freeze its transformations, and then we can reset its transformations. Let's go to the world origin. And we can do the same with the bottom one now. So let's freeze the transforms, and then reset the transforms. Now we can select the extended or the fully expanded coil and select the compressed coil, and then we need to go to the animation menu, set F2, and create a new blend shape. Okay, so let's give it a name. I'm going to call it spring, and we'll just create the blend shape. Now you'll see that the spring has been created. Here it is. It's on the first geometry we created, where 0 is actual maximum compression and a value of 1 is maximum extension. So we no longer need the extended coil, we only need this currently compressed coil. And we can therefore see the range of 0 to 1 will drive our spring. I'm going to delete some of the history associated with this. I'm going to delete the non-deformer history. That leaves us with the spring, which is exactly what we want. Okay, so now we need to control that spring. Well, first of all, there's a few things. If we were to select the top pivot, we'll notice that our top stopper has not been parented in, so shift select the pivot, parent, select the bottom one, shift select the pivot, P to parent, select our new spring that we've got operating. I'm going to parent that to the bottom one so that it moves as we move the piston around. So now if we select that, we'll see we've got all of those objects, and we select the top part. Obviously, the spring isn't working yet. Now you'd think that if we go in the Y direction, that would be what we'd want to control the compression of our spring. We want to drive that compression. But that's not quite true, because if we come out here, we can see that the Y direction isn't changing, but that we would need to compress and expand. We need a little bit more intelligence than just using the Y direction. So what we're going to use for that is a node, which is we're going to create a measuring tool. It's a distance node. And I'm going to V-snap the first point and V-snap the second point somewhere on our pivots, and now I'm going to move them and position them where we need. Okay, so that it actually creates two locators, and in between is a distance node. So the pivot is a little small. If I scale this up, say to 3, now I can click on the X direction and V-snap. Let's do the same with the bottom one. Scale it a little small. Set that to 3. V-snap in those two directions. Okay, let's go on the side as well, just make sure. Z direction, V-snap. Let's make sure we just get the locator, not the distance. V-snap. Okay, they should all be centered up now. And that looks good, and we can still reach our locators. So we can see here that we have a value of 12.28 when the piston is fully extended. And 12.28 down to, if that was to compress down to something like 9. So we can see that when it's at 9, it would be fully compressed. So somehow we need to use that value to drive the blend shape value from 0 to 1. And we're going to do that with a set range. So I'm going to open up the Hypershade. I find this very easy to use, which by default comes in with your materials. We're not going to use the materials, we just want the work area. So let's just view the work area. Now if we click on this dimension, we can map its input and output connections. We can see here this is the dimension, but we have a shape node. Let's open up the attributes on the shape node, and we find that there's an attribute called distance with a value of 12. By the way, I opened up the attribute editor doing a Control A. So the distance is what we want to use, and we know that the value is 12.28 down to about 9. And the object we want to drive is our spring. So let's map its input and out connections. All very complicated. But although it looks very complicated because there's a lot going on here, the object we need is the spring blend shape, which is this node here. Okay, so somehow we've got to link these two together. Well, I'm going to select the distance, and I'm going to select the spring, and I'm going to map both of those at the same time. So here we have them. Now, as we saw earlier, it is in fact this distance shape node that we're after, and this blend shape node. And somehow, when the distance is 12.8, we want the blend shape to be a 1, and when the distance is 9, we want the blend shape to be 0. So what we need to do is change that range, so as we feed them in. There's a node that allows to do that. This is the set range node. I'm going to middle mouse button click, drag and drop that into the work area. Okay, so now I can middle mouse drag from the shape node over to the set range, and you can't quite see it, it's just off your screen. Let me do this again. So if I middle mouse button drag and drop, I'm going to select other. This will bring up the connection editor. So we have here the distance shape node and the range node. So if we scroll down, we'll find there's the distance parameter that we're after. And we can take this into any of the values of the range node. We're going to bring it into value X. You can use any of them. It just has 3 nodes, so it can do 3 calculations. Just remember that if you bring it into X, you're going to take the value out from X as well. Okay. If we double click on our shape node, our range node, we can see that the current value is now being fed in. It's not something we can change. So we know that our maximum value, full extension, is the current value, which is 12.281. We know that the minimum value that the node will probably be is around 9. We may have to tweak that value later. And when it's at 9, we want the minimum value to be 0, fully compressed. And when it's at 12, we want the maximum value to be 1, which is fully extended. Okay, that should be all we need to do. Then I can middle mouse drag and drop over here, select other to bring up the connection editor again. And now I can take the out value X, since I use the input value X, and I can bring this into the weighting for the helix. Okay, let's have a look and see what's happening. So now I'm going to move this locator, and as I move the locator, I can see that the spring is compressing to a point till it's fully compressed and not beyond, and the same with the expansion. However, it's obviously not driving the piston. So we've got this final part to set up. What we need to do is let's open up the hypergraph hierarchy, and we can see here that we've got our pivots and we've got our locators with our distance node. I'm going to create a group with our pivots and call this our piston group. So Control G to create a group. Move this over slightly, and let's call that a piston group. And then I'm going to take all of our other items which are really part of our rig, and I'm going to Control G to create a group for those and call that the rig group. Okay, pretty straightforward. So whenever we move this locator 1, we want the top pivot to move. In other words, the top pivot is currently set to rotate and aim to the bottom one, but we'd also like it to translate to match whatever this locator is set. We're going to do that with a constraint. Since we've got these 2 separate nice hierarchy structures, we're going to keep them separate. We're going to keep geometry separate from our rig.